Hopefully you feel comfortable handling two of the special cases that often come up with projectile motion. That is when an object is shot off horizontally or when it's shot at an angle. But we should be able to apply the basic rules of projectile motion to any situation, even ones where the path is asymmetrical, like the ones we'll see in this video. So what's meant by an asymmetrical path is when something is launched maybe from the ground, but perhaps it lands on top of a building. Okay, that would be an example. Or maybe you're on the top of a hill. Here's your hill, okay, and a ball or something like that is launched and it comes down and hits the ground. So the key thing here is that the starting and ending positions are not the same, and it's being shot at an angle. So what's similar to previous questions that you might have looked at is that in the horizontal direction, we still consider the speed to be constant. Our acceleration in the x direction is 0. Okay, and the acceleration in the y direction is still governed by gravity, and so it's going to be negative 10 meters per second squared in most situations. You certainly can consider down to be the positive direction, but most people have better success by sort of thinking the way a number line normally is written. And very important that when you're given an initial velocity, that you break that into components using what you've learned about vectors. You really cannot do these sorts of questions if you use the initial velocity as it is. You got to break it into parts. What's different though is, unlike some of our earlier questions, you cannot use symmetry. Okay, because the object does not start and end at the same level, it does not take the same amount of time to go up and to come back down. And the speed is not the same at the beginning, at the end. So definitely keep that in mind. And although the example that will be shown in a minute does not use the quadratic formula, there are many situations where that's going to be necessary. So just kind of be ready for that. All right, so of course stop the video if you need to read through the question or to write it down if you don't have it in your notes already. All right, so here we have a firefighter. The distance to the building is 60 meters. Shooting the water at 80 meters per second, pretty high, but that's sort of typical for a fire hose, at an angle of about 55 degrees. And we are asked to figure out how high on the building does the water strike. So just as we have done before, it's a good idea to organize our information. So in the x direction, or the horizontal direction, we might want to notice that the distance is given as 60 meters. I'm going to label that x in my work because that's what I'm used to doing. We are given an angle and a speed, and that together will allow us to find the horizontal speed. So we'll take 80 meters per second times the cosine of 55 degrees. All right, and that gives us a value of 45.89. I do like to keep an extra decimal place or so with my speeds so that my answer makes sense at the end. So that's the information in the x direction. In the y direction, or the vertical direction, I can also use the speed to figure out not just v sub y, but the initial v sub y, so v sub o sub y, and that's instead using the sine. That should be a higher value because the angle is greater than 45 degrees, and in fact it has come out to be 65.53 meters per second. All right, and that's really all I know. So taking a look at this information, I can add in, the value that the acceleration in this direction is going to be 10 meters per second squared, and since I'm thinking of this v sub oy as a positive, then I'm going to consider this acceleration to be negative. Consider up to be the positive direction. But I really don't have enough information in my purple values in my y direction to be able to find anything. But what I can do is I can find the time in the x direction. You know, I can think about that since I have a constant speed, x is v times t in that x direction. And so if I want to find time, I would just take my distance and divide by the speed. So 60 over 45.89, and that gives me about 1.31. Okay, so that's the time it takes for the water to either go up and hit the peak and come down again, or it might still be on the way up. It really doesn't matter, okay? The next step here, I'm going to be just using the fact that the vertical distance that it travels upwards, the vertical position, is dependent on the initial vertical position plus v sub ot in the vertical direction, v sub oyt, plus 1/2 at squared. Again, all in the y direction. Now, this can handle, you know, any sort of time. I don't need to think about, oh, does it go up, does it come down? That doesn't matter. I just need to know the value of t and trust that this function, which would take the shape of this parabola, can handle everything. The problem doesn't really give me the height of the firefighter or where he or she is holding the hose, so I really can't consider a y sub 0, so I'm going to have to just sort of assume it's 0. My initial velocity in the y direction I found to be my 65.53. I'm going to take that times the time we found earlier. My acceleration, again, I got to make sure I put that in as negative. Otherwise, if it's positive, I'm saying that the water just keeps on speeding up as time goes on. And in fact, it slows down until it reaches the peak, and then it speeds up. But the equation takes care of that change. I don't need to consider that. I just need to consider initially how does the velocity and the acceleration compare in terms of direction. And then I'll just go ahead and label this h since that's what the problem told me to use, but you know, you could leave it as y. Calculating this all out, it comes out to be 77.3 meters. Okay, so again, it's very similar in our thinking to all the other questions. The key idea is to keep your vertical and your horizontal numbers completely separate, and the only thing that, you know, sort of connects or we see in both situations is the time. Okay, the time is here, found in the x direction, and then we use that in the y direction.